Hi everyone, welcome to Data Nutshell. Last time we talked about logical versus physical storage and how system retrieves files. But there's one big problem left. What if something breaks or what if servers fail? Disks fail all the time, machines go down, network glitches happen. And if you keep only one copy of your file, then one failure means your data is gone forever. That's why we need redundancy, that is, storing extra information so your file can survive failures. The simplest way to implement redundancy is replication. That is, take the file and make multiple copies of it. So if you keep three copies of the same file on three different machines, you can survive two failures. So then even if two of those machines crash, you will still have one copy of your data left. It is very simple to implement, but it is very expensive. You will have to pay three times your storage cost. So imagine you have 1 TB of data. Now you will need to pay for 3 TB of space just for safety. The second way to implement redundancy is a bit smarter. It's called parity. So, replication is wasteful. Instead of storing full copies, we can store some extra information that can help us rebuild the lost data. This extra information is called parity. What is parity? Parity is kind of a checksum or a mathematical relation. It doesn't duplicate the data, but it just contains enough extra information to rebuild some of those missing pieces. So let's see a simple example. Suppose you have two blocks of data, A and B. A's value is 7 and B's value is 5. So instead of storing multiple copies of A, B, what you can do is you can store one extra block called C, and C's value can be A plus B. So you can store three blocks, A 7, B 5 and C 12. So now what happens if you lose A? You can reconstruct A with C minus B. If you lose B, you can compute B with C minus A. And if you lose C, you can recompute C with A plus B. So with just one extra parity block, you can survive the loss of any one block. So this is exactly what systems like RAID do. RAID RAID. So we have multiple types of RAID. Say in RAID 5, we split your data across disks and we keep one extra disk for parity values. And you can survive one failure with RAID 5. In RAID 6, we keep two different parity calculations and two different parity disks, so you can survive two failures. So this is much cheaper than replication because you are not paying for three times the storage, you are just paying for that parity disk. So what's the trade-off? Trade-off is if you can rebuild from one failure or two in case of RAID 6, but not more. And that rebuilding requires mathematical calculations and disk reads, which is a bit time consuming. Still, it's a brilliant step forward. Instead of wasting full copies, we are using smart maths to protect the data. Now, big cloud providers like Azure and AWS go even further. They use more advanced maths called erasure coding, which is like parity but much more complicated, and it can survive multiple failures at once. So, before we get into that, we should clearly understand the concepts of replication and parity, which is the foundation of redundancy. I hope you liked the video. If you like the video, please press like and share and subscribe. Thank you.